Number 17. Okay, this problem seems really daunting. We have this polynomial, 3 roots in the complex plane. What is the area of the triangle? What? How are we possibly going to figure that out? We have these 3 points, these roots, and then we're trying to find this area. Like, how are we going to, first we have to figure out the roots. So now here's kind of the tricky part here, and that's kind of the dilemma I was in when I was doing this problem. Are we going to solve for the points directly, or are we going to somehow, find a shortcut to the area? And this kind of balance, figuring out, do we want to find everything individually and then find out the area, or do we want to find the area directly? And it kind of depends on the problem. Like in some cases where, let's say in a geometry problem, we want to find the sum of 2 different lengths or something, right? It's not maybe ideal to find the lengths individually because that might be a lot more computation. So it's kind of figuring out, are we trying to solve for each of the roots first, or should we actually just find the area? And there's not really an easy way to find, a nice formula for the area. Like you could use the complex shoelace formula, but that's a little bit messy. So in this case, you might just think, okay, maybe let's try just solving for the roots instead. And one really key indicator that we're trying to solve for the roots directly instead of the area is we have this really nice symmetry going on here, right? Let's say z plus 2i is w, right? Let's say it's w. Now we can get w minus i, right? W plus I, and w itself. That's z plus 2i. Plus 10 equals 0. And the really nice part here is we don't actually care about what z is. If you can find the roots of w, if you can find the 3 roots of w that make the 0, whatever z is, it's just going to be shifted, right? Z plus 2i, z is equal to w minus 2i. We would just shift all of these points down 2 units to get our new triangle for z. And it's the exact same area because we're just translating the triangle down. So it's the same thing as just finding the area of the triangle with 3 roots here, and that will just give us whatever we wanted here. Okay, so how do we go about this, right? First of all, w minus I, w plus I, immediate difference of squares. That's w squared minus I squared, w squared minus 1. So that's w squared plus 1 plus w plus 10 equals 0. W cubed plus w plus 10 equals 0. Okay, we have a cubic, 10. Maybe we just try some integer roots, right? Rational root theorem. Maybe it's possible there's not, but given that this is we're trying to solve for the area, most likely we're going to find some nice roots here. Okay, what if w is positive? Well, clearly this thing is going to be positive. There's not going to be any positive roots here. What about w negative, right? Let's say negative 1. If w is negative 1, we get negative 1 plus negative 1 plus 10, clearly not 0. What about negative 2, right? Anything that divides 10. And this is kind of how you would approach it in a real contest, right? Plus negative 2 plus 10, that's equal to 0. Wow, that works. So w equals to negative 2, that works. Okay, so now all we have to do is some synthetic division, right? Negative 2, 1, negative 2, right? Negative 2, 4, 5, negative 10, 0, right? It's just standard synthetic division. And we get w plus 2 times w squared minus 2w plus 5 equals 0. And this is so we have our root negative 2, right? This one, the easiest way is honestly difference of squares as opposed to quadratic formula. So we have w minus, for w squared minus 2w plus 5 to equal 0. We can just say w squared minus 2w plus 1 equals minus 4, or w minus 1 squared equals minus 4, or w minus 1 equals plus or minus 2i, or w itself equals 1 plus or minus 2i. So now we have our roots, negative 2, right? Let's try and plot this out. Negative 2, this is not a very good graph. Negative 2 is going to look something like, it's just going to lie here, 1, 2, negative 2. 1 plus or minus 2i. Okay, 1 plus or minus 2i. So this point and then this point. And we're just asked to find the area of this triangle. And this is pretty simple. We know this is going to be 4, right? Because this is plus 2i. This is minus 2i. The difference is 4. And then we have that the difference here, if this is 1, this is negative 2. So this is going to be 3. So this height over here is 3. So 1/2 times 3 times 4. We get an area of triangle of 6. What a nice solution, right? The key thing here is just symmetry. just use that symmetry. You got to use it. When you see this kind of symmetry, it's there for a reason, right? Just immediately go use it. And then, that's kind of figuring out, is there any shortcut to find the area itself? And we see here that the easiest way is just solving for the roots themselves. And we have a clean solution using the rational root theorem. And I hope you enjoyed this video. Thanks for watching.